Hello again. There's been a slight change of plan due to problems with the pendulum, so this video just finishes off the design and testing of the motor drives, and I'll tackle the pendulum next time. Here's the drive so far. The remaining motor plates are fitted, and the 3 concentric shafts terminate with these flanges, one for each hand. If I turn them manually, you can see the belts moving for each motor. Now these 2 attachments hold extra bearings for the minute and hour shafts. Now this is one part of the design I never really liked. I was worried the weight of the hands would cause the concentric tubes to rub together and wear through over time. The second hand is okay, as its bearing is right next to the flange, but the minute and hour shafts are a long way from their respective bearings. Now I couldn't think of a way of supporting them once they'd left the front plate without interfering with the hands. It's a topological mindbender, and the best I could come up with was to have these extra bearings suspended by a thin rod or wire fastened to the top of the clock face. It's very clunky, so if you've any suggestions, please comment below. Right, now for the real test. I'll connect one of the motor assemblies to the controller and see what happens. Here's the display as before. The lights show a sensor magnet has been detected, and it's not too weak or too strong. And the AGC value is roughly in the middle of the range. All good so far. I'll get the controller to start a simple 1-second timer and the motor should step round. Now it's not exactly correct, as there are rounding issues to sort out when converting degrees to step numbers, but that code is already in the old Lash-Up prototype, so I just need to copy that across later. I've also made a simple test for the sensor by storing the sensor reading for the 12 o'clock position inside the code. If I press this button, it turns the motor until it reaches that position and then carries on ticking. And this is repeatable because the hands are locked to the motor shaft via the tooth belt. So if the power goes off, or even if the hands are moved manually, that reference value will not change. So it's just a case of coding or calculating sensor values for all 60 positions around the clock face, and the controller will have full knowledge of where the hands are at any time. Okay, that's all for now. I'll go and test some pendulum designs and hope to have something to show next time. See you then.